I'm glad you didn't go anywhere. So let's see another question, another amazing question. Physics is easy with the right teacher. Alright, so let's go. This is a question under the principle of flotation, where we say that a body floats when before it is totally immersed in a liquid, the upthrust exerted on it by the liquid equals the weight of that object. Okay, so with that in mind, you already know that upthrust for flotation is equal to the weight of objects. That is based on the principle of flotation. Alright, and we know that upthrust is given to us as the density of the liquid times acceleration due to gravity times the volume that was immersed in the liquid. This is equal to the density of the object that was immersed in the liquid times acceleration due to gravity times the total volume of the object. Okay, so in this question we're told that an iceberg floats in fresh water with the parts outside the water surface. Calculate the fraction of the volume of the iceberg which is below the water surface. The fraction below the water surface is simply the fraction of the volume that was what? Immersed. So our attention is to try to obtain the volume of the iceberg that was immersed. We were given from this question that the density of water, that's the liquid in this case, is 1000 kilogram per meter cube. We're also given the density of the iceberg, I'll call this one rho ice, as 917 kilogram per meter cube. Okay? Nothing was said about the total volume because we're asked the fraction of the total volume that was immersed. Okay, so my attention will be turned to this now. Rho W, representing the density of water, will be times gravity times volume immersed, which is now equal to rho ice times gravity times the volume of ice. Okay, so knowing fully well that this G will cancel this G, and I'm looking for VIM. If I make VIM solely to the formula, that's the volume immersed, will be equal to the density of ice times V ice, which is the total volume of the iceberg, over the density of water. Alright, so I'm trying to look for the volume that was immersed. That volume is a particular fraction of the total volume of the ice. So volume immersed will be equal to rho ice is given to us as 917. This is times V ice over 1000, which is the density of water. So if I divide 917 by 1000, that will give me 0.917 V ice. Okay, so this is simply our answer. The fraction of the iceberg that will be immersed is simply 0.917 of the total volume of the ice. Okay, so the total volume of the ice is just 0.917 that will be below the water surface. Okay, you see it's very easy from the understanding of flotation. Thank you very much once again. If there is anything that you don't understand again, please do it to drop your question in the comment section, and I'll be very much available to help you out. Thank you very much.